Oh, hello. I'm glad you asked. You want to know the difference between a condenser microphone and a dynamic microphone and which one you should buy. That's a good question. It all boils down to the fact that they just have different transducers. Okay, they have different methods of transduction. Because they have different kinds of transducers, they're going to have different sonic characteristics in theory. And because they're going to have different sonic characteristics, they're going to have different applications. What is a transducer? A transducer is simply something that takes one form of energy and converts it into another kind of energy. And in the case of microphones, they take physical energy in the form of sound waves traveling from my voice or an acoustic guitar or anything, and they convert it into electrical energy, into an electrical signal that gets sent down the microphone cable into a mixing board, into a compressor, whatever. Physical, electrical. That's what a microphone does. Well, in both a condenser microphone and a dynamic microphone, there's something that vibrates in proportion to the vibration of the sound waves making contact with the microphone. And the thing that vibrates in proportion to the sound waves making contact with the microphone is the diaphragm. The diaphragm vibrates as sound waves make contact with it. Both the condenser microphone and dynamic microphones have a diaphragm. And the diaphragm moves in proportion to the vibration of the sound wave. So as if the vibration of the sound wave is vibrating a lot, so is the diaphragm. If it's a weak vibration, the vibration of the diaphragm is going to be proportionally weak. Now think of our own diaphragm. Our own diaphragm down here in our stomach. As you breathe in, your diaphragm moves proportionate to the amount of air you breathe in. When you breathe out, your diaphragm is proportionately moving to how much air you breathe out. So same with this, okay? Air comes in, the diaphragm moves accordingly. We have a diaphragm, and we're going to talk about dynamic microphones now. This is a Shure SM57. This is the workhorse of every single recording studio. But in here, in this little head, there is the diaphragm, and then attached to the diaphragm is a little coiled wire. Now that coiled wire is suspended in a magnetic field, okay, and the magnetic field is generated by a magnet that's inside the head of this microphone right here. Okay, now what happens is as the diaphragm moves, because incoming sound waves are knocking the diaphragm, I might say diagram in this video, but if I say diagram, I mean diaphragm. As the diaphragm moves, the coil is going to be moving as well, but it's going to be moving within a magnetic field. Now, as you may remember from, that's just Twitter. Now, as you may remember from high school physics, if you have like a wire moving through a magnetic field, is going to create some current in that wire. That's what happens in here. As the coiled wire is moving in the magnetic field, it creates current in the wire. And then there you have your electrical energy, and it travels out into, as I said before, whatever. Now, it's extremely important to realize that the electrical signal that's sent out of the microphone is proportionate to the sound waves coming in, making contact with the diaphragm. But it would make sense, because you're going to have the diaphragm moving. The diaphragm is going to be moving the coiled wire in the magnetic field, and so that amount of current is going to go out. So the amount of current is going to be proportionate to how much the diaphragm and the wired coil is moving, which is moving in proportion to how much air pressure is being applied to the diaphragm. Okay, so that should make sense, right? Because if you have high sound pressure coming and making contact with the diaphragm, you want stronger electrical signals going out, right? If you're just whispering just a little bit, you want to make sure that little weaker signals coming out, right? So that's the idea. And voila, you have my voice right now because I'm using a condenser microphone, or I'm using a dynamic microphone to talk to you. This is a condenser microphone. This is an AKG 414. These are all-purpose great microphones. Different kinds of transducers. Now, this also has a diaphragm. This diaphragm is a very thin plate, and it is movable. It moves around just like the diaphragm in here. It moves. Now, the diaphragm in here is positioned parallel to another plate, very closely to it. But the other plate, the back plate is what it's called, doesn't move. It's rigid, it's stationary, it stays in one spot, while the diaphragm can move. Now there's a battery, a power supply. That's why condenser microphones require phantom power, external power, is because there is a charge that needs to be applied to the plates, and it creates a polarized charge. Okay, so the front plate will have more negative energy, and the back plate will have more positive energy, or vice versa. So now as sound makes contact with the diaphragm, it's going to change the distance between the back plate and the diaphragm. Okay, the diaphragm is going to be displaced with respect to the back plate. Now, as a quick side note, this whole little situation going on here where we have the back plate and the diaphragm and the space between with the charge, that's called a capacitor. And capacitors used to be called condensers, and that's how condenser microphones got their name. Okay, so we have the capacitor, and we have the diaphragm is going to be displaced with respect to the back plate. Now what that's going to do is it's going to bring the diaphragm closer to and further away from the back plate. That's going to cause some electrical fluctuations, and that's going to generate the corresponding signal that's going to be sent out of the microphone. Now, it's a very weak current, and so in condenser microphones, they're going to have to electronically amplify the signal going out of the microphone. And that's where you're going to get tube condenser microphones, FET condenser microphones, etc. That has to do with the electronic amplification of the very weak signal. And so that's how condenser microphones generate current. And so that's the difference. Okay, this one has a little wire that moves in a magnetic field that generates current. Bam, you got your electric energy. The way that you get energy out of this one is you have a diaphragm displacing, and that's going to cause some type of energy fluctuations that get sent out as the electrical signal, and you get transduction. The consequences of those differences are extremely general. It's my belief that having this understanding of the different types of transducers is practically useless. Okay, so good for you for watching. The sonic differences that are theoretically implied by the different transducer types is just interesting, really. The most important thing to do and to know is what your microphone does in different situations, what your different microphones do in different situations. That's the most important thing. Now, in general, they're going to have, in theory, these are going to have different sonic qualities because of their transducer types. We might say, for simplicity's sake, that a coil wire in a magnetic field isn't as easy to move, and it's easier for this diaphragm in here to move and create the energy fluctuations that generate the current. And so these microphones tend to be a lot more sensitive. Condenser microphones, in theory, are going to be more sensitive. They're going to respond a little bit better to higher frequencies, and they're going to have a little bit better transient response in theory. Transient is just how fast it's able to get the oncoming sound wave. So if I snap my fingers, right, some microphones would be able to pick that up very quickly. They're going to get that very first part of that sound wave, that disturbance in the air. If you're going to be miking a nylon acoustic guitar, for example, and you want to hear every single nuance, condenser microphone might be something you want to reach for before a dynamic microphone. If you have a hardcore screamer going, you want to probably reach for a dynamic microphone because in general their build is a little more rugged, okay, and they're able to handle higher SPL, sound pressure levels, than the little flimsy diaphragm of a condenser mic. But that's kind of what I want to explain is the difference. This is able to take a little bit more heat. It's not going to capture transients and higher energy as well, in theory, as a condenser microphone. I hope you guys are sufficiently educated, or at least feel sufficiently educated. If you did learn something, then hit like and subscribe, because I helped you. Now you better help me. And anyway, I hope to see you guys next time. Thanks for watching.